Hello everyone, welcome to the next lecture on the probability and statistics. Today we will discuss about what is the ordered statistics. Myself Dr. Garg, working in the School of Mathematics. So as we all know that the ordered statistic is one of the most useful concept in the statistical science. It is widely used in the various of the applications like modeling, race, insurance and many more are there. What is the logic behind is that this ordered statistics are used the sample value which are writing in the ascending or descending order, that's depending upon you. Now the theory which are related to study this ascending order behaviors, that is the study of the ordered statistics, deal with the application of these ordered values and their corresponding functions. So before I just explain you in detail what is the ordered statistics, let me explain you through some examples are there. So first of all, we just consider that there are the n variables which are IID. I hope all of you have must know about what is the meaning of the IID. So if you are not know, like let me briefly explain what is the meaning of the independent is. So whatever the value you have taken as a random variable is not influenced by the values of the other variables. What is the meaning of the identical? This is the meaning of the independent. What is the meaning of the identical is? That is the PDF or the CDF of the random variable x1, x2 and x3 all are same. That's the meaning of the IID. Now let us consider the example. If we have the four persons having the different heights are written as here 65, 74, 59, 72 and so on, then how you can get the ordered statistics? The rule is very simple. You have to firstly arrange this series in terms of the ascending order, like 59, then 65, then 72 and this. So what you can call this one? This is the first smallest number of the given series. What is that? This is the second smallest number of the given series. This is the third smallest number of the given series. This is the fourth smallest number of the given series, or you can also say this is the largest number of the given series. So we will define this first smallest, this bracket is called as the ordered number. This is x1, this is x2, x3 and x4. Or in general, we can call as the kth smallest number are there. What is the meaning of this is? This is the second smallest number of the given series. And this is called as the kth order statistics. So if someone asks you what is the third order statistic, it means you have to find the third minimum value or the smallest value from the given series. Now based on this concept, we will generalize this series like here. If xi's are my IID which are taken from the populations, then we will firstly write in the ascending order like here. What is the meaning of this x1 is? That is the first element of the smallest first element of the series, the smallest element, the second and so on. So what is the meaning of that? You can say this is nothing but my kth order statistics, and we will generally denote it as of x of k. The general notation of the kth order statistics is here. Make sure that it's a very important point. Remember that xk is a different from the x of k. Why? What is the xk? Xk is nothing but my ordered statistics, and what is the xk is a kth random variable. There is a huge difference between them. For example, if I consider here, then what is that? This is the second variable. This is the second smallest element of the variable. So xk takes the value of the xk if xk is the kth smallest element. It means if I say second, if I consider this is my here, then here, then what is the my x2? What is the second smallest element in here is 9, and although what is the x2 is, this is my x2 again. Now it is the same. Why? Because if you arrange them in the ascending order, the numbers are my here. But what is my x3? That is the third smallest element in there, that is a 10. And what is my x3 in this example is 7, because this is my given xi series and this is my given ordered series are there. So if you look about that, this is my x3, this is my x ordered statistics are there. So it sometime it may or may not be equal depending upon that whether it will takes the exact value of that in the ascending order. So make sure that xk is a different from this x series are there. Now once you will define this here, we will define this, the meaning of all are there. What is the meaning of this is? This is the smallest element of the given series, that is set of the minimum value. We can write as minimum of xi's, that is called as x1. What is the x2 is there? If you look about this is how you can define this one is, that is the second smallest element in the given series. How you define the second smallest element is, that is you can find the smallest element all except the previous one. Similarly, how you can define the x3? Smallest element of all these series except from the first and second. Similarly, how you can define the kth smallest element or the kth order statistics is you can find the minimum element except from the previous k minus 1. Similarly, you can find the nth are there, you can find the smallest element, that is the minimum of this, except from the here. Or if you find this, you can also call as this is nothing but the largest element of the given series, or called as the maximum. So that's the basic notation which is used in the standard notations are there. X1 is always with the minimum of this, Xn is always with the maximum of this. We will see in a couple of examples later on. So what we will see upon there, that is, if you have the given series like of the here 10, 7, 9, 11, 8 and 4, then if these are my xi's, if you arrange them in these xi order, then it will be my 4, 7, 9, 8, 11, 10 and 11. So what is the meaning of that? The x1, what is that this is the value of the first position, x2 is the second smallest elements are there, x3 is my third smallest element. What is the meaning of that? Ordered statistics depend only on the order of the values, not on the values themselves. Why? If I consider the another series, say 3, 7, 8, 4 and 5, then what is the ordered statistics of this are there? So you can write them 3, 4, 5, 7 and 8. So this 4 is the second position. Look at that, in here the second position is my 7. So if you look about the x4, if in this series it's a 7, in this series is my 4. So that's only depends on the order of the value and not on the values themselves. So do you remember that any of the term which we deal with them? Yes, the median is the ordered stat, because median is also depending on the position only. It is not depending upon all the observations. So that's why median is my ordered statistics, while mean is not that. So whenever we are talking about the ordered statistics, the median will be preferable one. Also, if you look about the various formula of the like minimum, maximum and so on. So if what is the minimum is x1, what is the maximum is xn. How you can define the range is, all of you know that what is the range of the series is, that is the maximum minus minimum. So can you define that maximum is my xn, minimum is my x1. So can I define this as of here? Yes, that's true. How you can define the first quartile, that is nothing but the 25th percentile of this. This is my 75 percentile of this. So you can define as of 25 percentile 75. Based on this Q1 and Q3, you can define the interquartile, that is nothing but the Q3 minus Q1. How you define the median is as you define in your there, but the difference is here is you have to use the ordered statistics, xn plus 1, this is the ordered statistics are there. All of you know that how you can calculate the median is, in general you have to take this position, this when it is a odd, and evens when this is average of them. But now here is the ordered, so you have to write like here. Now how you can define the first, second and nth order statistics here. So remember, x1 is, as we discussed, the smallest sample element, so we call as the minimum. x2 is nothing but the next smallest element of them. xn, that is the largest element, or called as the maximum of them. Once you are defining this, for example here, you can see what is the smallest element in there is 2, this is my x1. What is the next smallest element is there is, this is my 14, so this is my x2. What is the xn, that is the largest element is here, this what is the n in this case is 6, so this is my x6 of the largest element is 27. Similarly, you can find the third order statistics. What is the third smallest element in here is, that is my 15 and so on. How you can define the PDF and CDF of this first order, nth order or any of the order are there. So how you can define that? So as we know that if you have any random variable x, we will define the small fx as a PDF, capital Fx is my CDF, and the relation between the PDF and the CDF is given as here. Based on this notation, we can define, based on this we can define the first order statistics PDF, nth order statistics PDF, and in general the kth order, k may be the 2, 3 and so on. So if I consider as xi is my IID, what is the meaning of the xi's are there? IID are there, that is the PDF and CDFs are same. So x1, x2, xn all are same, I call as fx, fi, x1, x2 and these are my PDFs are there. So all the PDFs and the CDFs are same. That's the definition of this identically distributed. Now we can start with the firstly nth order. What is the nth order is? What is the meaning of the n order is? That is nothing but the maximum of x1, x2 and xn, that is the order are there. How you can define the CDF? Once you know the CDF, we can define the PDF as of its derivative. What is the definition of the CDF is? All of you know that what is the definition of the CDF? Probability x is less than of the x. But now we define the nth order, so this is the nth order. What is the value of the xn is maximum of this. I can substitute here. So look at it. What is the meaning of that? Whatever the value of this, that is a less than of this. Whatever that, it means each of the numbers are of less than of it. Now since since this x1, x2 and x3 are my random variables, they are not the order statistics, because if it is order statistics then it is the x1, but now here is only the x1. And what is the xi's are? They are independent is given to you. Why? Because it is IID. So once they are independent, what is the probability of the x comma y? This is nothing but the probability of x into probability of y. So I can write this term as of here. This is the x, x1 and x1. What is that? This is nothing but the CDF of the x1 variable. This is the CDF of the x2 variable. This is the CDF of the xn variable. But since they are the identical also, so what is the meaning of that? Each of the distributions are same. So we can fx, fx and fx. How many times? It has n times. So therefore, this is the CDF of the nth order statistics. Once you know the CDF, you can easily calculate the PDF by using their derivative. What is the nth derivative of this is? If you take the first derivative of this, what is that? This is of n minus 1 and derivative of this capital F. So what is that? What is that? What is the value of this? This is nothing but my PDF of the random variable x. So I can write like here. So you must remember this is the nth order PDF of the order statistics. Similarly, you can define the order statistics of the first order, that is the x1, which is defined like here. Now since x1 is here and this is there, so what is the meaning of that? That is minimum of x1, x2 and xn is less than of the x. It doesn't means that each of the xi's are less than x. It doesn't mean that, because it's a minimum of them. So what you can do is I can write this as 1 minus probability of here. Now what is the x of 1 is minimum of this. So if minimum of whatever the variable is greater than of something, what is the meaning of that? Each of the variable is greater than of the x. Again, since it is for here, now xi's are again independent. So we can write this as the product of this. I can write this expression also as of here, like x1 is greater than x, comma, x2 is greater than x, comma and so on. Since they are independent, so I can write this as x1 is greater than x, px2 is greater than x and so on. So that is in terms of here. Can you find the values of this? I can write this as of 1 minus probability of xi is less than equal to x. What is that? This is nothing but my CDF of the x, CDF of the xi. So I can substitute this value as 1 minus CDF of this. Now here, since again xi's are my IID, so each of the fi's are same. So this is nothing but my product of them. So this is the CDF of the first order statistics. Based on this, you can define the first order PDF. You can take the derivative of this, that is there here. So you must remember this also if you want to solve some certain MCQ questions in your GATE or the higher competition exam. Similarly, you can find the kth order statistics are there. That is, you can start from the kth order like here. You can write like here, this is the kth order statistics. You can substitute the values of this. What is the meaning of that? That is at least, what is the meaning of the kth order? That is the second order statistics. What is the meaning of the second order statistics is? That is the second smallest element is there. If you want to find the third order statistics, that is the third smallest element in the series P. So what is the xk, or you can say this is the kr, that is the at least k of the xi's are less than of the x, because if you find the xk, what is the meaning of that? Kth order statistic, at least ki's are less than of the x. What is the meaning of that? So if at least of the k, it means if you write the summation of them, j is from k to n, exactly j of the n's are here. So do you remember that which distribution will follow here? If you form exactly j of the n, exactly j of the n will follows like a binomial distribution. That's true. So what is the binomial distribution? That is the NCX p raised to power x q raised to power n minus x. So what is that? N is my n. What is the x is? How many out of j? So it means you can write this as of NCK. What is that? Probability of getting exactly n are there. Exactly n are there. So that is nothing but my CDF 1 minus of here. Now this is the CDF of this here. You can take the PDF of them. You can take the derivative of this. You can write like here. This is the PDF of this kth order statistics. Also, you can see that if what is the meaning of this? You can see if you substitute k as a 1, what is the meaning of that? This is the first order statistics. That is, here is my here. If you take k is equal to n in this, what is that? This is the nth order statistics. So we already defined that. So what is that? If n is k is equal to 1, what will happen? NCK is my n. If k is 1, it will be my 0. It will be my 1 minus f of x of n minus 1 of f of x. So what is that? This is a PDF of my x1. That's the smallest element. If you substitute the value of k is equal to n, n is 1, this is k minus this is here, n minus n is 0, and so on. So that means this is the k1 and kn is the special cases of this here. So look at this, all about that. How can explain you with the help of the one example. If you consider that the 5 random variables, all of from the uniform distributions are there over the length 0, 1. How you can find the first, third, or the fifth order statistics are there? That means you have to find the first order statistics, minimum of this. It is denoted as x of 1. Third order statistics, that is x of 3. What is that? This is minimum of all those except the first and second. X5, since there are the 5 elements are there, so this is nothing but my maximum of them. So that's a very simple, the first order statistics, that is a 1. You can use them here. So we can start from here. So since it is a uniform, so you can write as a PDF. What is the PDF of the uniform distribution? 1 upon b minus a. So 1 minus 0 is 1. What is the CDF of the uniform distribution is x minus a upon b minus a. So a is my 0, b is my 1. So you can write like here. Once you know the PDF and the CDF are there, you can start with this here. We know the first order statistics here. We can substitute the value of the n. How many random variables are there? 5. What is the CDF of this? Lies between 0, 1 is x. What is the n is my 5 minus 1. What is the PDF of this is my 1. So what is the answer of this? That is the first order statistics. PDF of the first order statistics is my here. You can find this value also. You can find this value also. K is in this case is my 3. You can write as a 5C3. What is that? This is nothing but x, k minus 1, and so on. You will get this here. Similarly, you can substitute the value here. This is this x, n is my 5 minus 4. This is my 1. This is my 5x raised to power 4. So this is the overview about this order statistics are there. In our next class, we will see how you can find the joint PDF of the order statistics, and we will see some more examples of them here. Till then, you can simply follow this link for finding the various videos. Best of luck, students. Happy learning.